Hey guys, Josh McKay with the Test Experts, continuing our calculus series. Last week we did we talked about antiderivatives or indefinite integrals, and we did the basic form. But I'm going to talk to you about a more advanced technique this week. We have a technique called U-substitution that's very useful in doing more difficult ones. So sometimes you get asked to find the integral of something like this, and it's not easy to use our old power rule. But there's this trick where we can rename the variable or redescribe the variable. So we're going to make a new variable called u, and we're going to set that equal to x squared minus 1. I got the x squared minus 1 right here. So we're setting u equal to x squared minus 1. Now it's important here, well, I could just rewrite this as u to the fifth, and I will do that eventually. But I can't take an integral of u with respect to x, so I need to get this dx turned into a du. How do I do that? Take a derivative of u. So what's the derivative of this? It's just 2x. And now I can go in and substitute. So notice this, I've got the x right here. So x, and this is actually 2x dx would be the derivative of u, because remember it's with respect to x. So notice, so x dx is almost this. So x dx, look, I could divide by 2 right here, and x dx would equal du over 2. So I can rewrite this now as x dx becomes 1/2 du, and I'm going to move the 1/2 out front because you can always do that with derivatives. So that becomes 1/2 du, and x squared minus 1 is u to the fifth. So this becomes my new integral. 1/2 integral of u to the fifth du, which then becomes easy. Remember from last week we can do, well, I need to rewrite my 1/2. Keep this, raise this exponent by 1, and then I put here 1 over that. So that gives me 1/12 u to the sixth. Now at this point, if I want, depending on how they ask the question, and I'll go ahead and write in my plus c, I can substitute back in my x for my u. So I'm going to get the final answer to be 1/12 x squared minus 1 to the sixth plus c. And that's a basic example of U-substitution. Now this U-substitution can be useful in a lot of different scenarios. You can imagine them with sines and cosines, with square roots, but there's lots of different applications of this, and we will give you maybe another example in the comments. But if you liked today's video, give us the thumbs up and subscribe to our channel, and we'll see you next time.